Hi, I built a tool called PerfLens. It takes internal Cerebras performance data and turns it into something that different people can actually use, whether you're a customer trying to make a decision or an engineer trying to catch a problem. So the problem in the audience. Right now, all the performance data lives in a spreadsheet full of technical columns. Only someone who already knows what they're looking at can make sense of it. But two very different people need answers from that data. The customer just wants to know one thing. Will this model keep up with my workload? So I built them a simple card, fast enough or not. In numbers, they'd recognize generation speed, how long before the first word appears, how many requests it can handle per minute. A green badge means go ahead. Yellow means double check your requirements, and red means it won't work for you. Well, for you, the internal engineer, however, needs something different. They want to catch problems before a customer sees them. And does the speed suddenly drop suddenly at high load? Are the numbers actually consistent? So they get raw data, a table that highlights anything suspicious, and charts showing how performance changes as you add more users. What I left out. Anything the spreadsheet doesn't tell us. No made up cost estimates, no guesses, just what's in the data. So the framework. I built it as a web app that runs entirely in your browser. There's no server, nothing gets uploaded anywhere. You open it, drag in your file, and it works. It works. That matters because this data is for unreleased models. I considered building it in Python, but that needs a server running somewhere. I also considered just exporting the spreadsheet to a web page, but then you can't upload new files. The whole point is that you can drag in a file for a brand new model, and it just works. No changes needed. Here are a few things I just assumed. On the data, the column names might change slightly between versions, so the tool normalizes them automatically. It actually handles two different versions of the spreadsheet format already. On the audience, customers don't need to know what batch size means. Engineers do, so each view only shows what's relevant to that person on where this runs. It's a simple static website, no login, no backend, works on any free hosting service, which is all this needs. And now this is what I would change, or this is what would change. With more data, if we had more models to compare against, we could be smarter about which test cases actually help us tell models apart rather than keeping ones where every model gets the same answer anyway. With real production numbers, right now, everything is projections. If we had actual measured results, the engineer's view could show where projections were wrong, and the customer badge could say we're 90% confident instead of just go. With more time, I let customers type in their own requirements rather than using my default thresholds. What's fast enough is different for every workload. Model sizes. Here's how you can roughly guess a model size from the numbers. Bigger models are slower per chip because they have more to compute. Models G, I, and E are the fastest per chip. Most likely, small models under 10 billion parameters, A, F, H, J, K, are in a similar range. B and D are noticeably slower, probably medium-sized, and C stands out. It's the slowest by a big margin, roughly half the speed of the others. That almost certainly means it's the largest model in the set, probably 70 billion parameters or more. Profile use cases. Each traffic describes a different type of workload, how long the inputs are, how long the outputs are, and how much gets reused between requests. Profile 1. Long inputs, short answers, lots of reuse, someone asking questions about a document. Then profile 2. Long inputs, long outputs. Nothing is reused, writing or deep reasoning tasks. Profile 3. Medium inputs, short answers, everyday chat. Profile 4. Short everything, and it's quick back and forth. Profile 5. Long input, medium output. Is good for summarization. Profile 6 is the most unusual. 60,000 token inputs with 90% reuse. That means nearly everyone is sharing the same context, like a call center tool with a huge shared script. Profile 7 is long inputs, long outputs. This will be good for coding agents that read a lot and write a lot. The practical point. Profiles with lots of reuse are cheaper to run. Profiles with huge unique inputs and no reuse are the most expensive. Those customers need more memory per chip. And to close out, this is PerfLens. Drop in any performance file and both views render instantly. No setup, no code changes needed for new models.